In 10.3, radical expressions, we're going to start learning how to simplify. So something you need to keep in mind is that if we have two radicals that are being multiplied, we could actually put that underneath 1 and multiply and then simplify that out. As long as they're the same, as long as this is a square and this is a square, then we can do that. So this means we can go backwards. So if I had, let's say, the cube root of 8, I could split it apart and say 2 times 2 times 2, or we could even write it as the cube root of 2 and do this 3 times. So all of these are equal. So this is, we need to keep this in mind, that we can take something that's underneath and split it into its factors, or we can have things that are underneath the radical sign that are being multiplied that we can then multiply underneath our little radical sign. This will help us when we go to do our simplifying. The other thing we need to remember about radicals is that you cannot have a radical sign in the denominator of a fraction. So if we have, for what we're doing now in this section, we've got this fraction. So just like what we saw a while ago, where you could split it apart, you can do the same thing here. You can split this and then simplify what you can. We can take the square root of 100, so that's good, since I just said we can't have a radical, we can't leave a radical in the denominator, and so this would simplify to this. In a future class, we'll learn how to take care of a number that's in the radical sign that is not a square or a cube or whatever, an even number that will come out. For now, for this section, everything that's in the denominator will be able to come out as a whole number. All right, so we want to simplify this. And we've got the cube root, so that's important to pay attention to here. When I look at this, I'm going to go ahead and split it apart. And then when I'm looking at the cube root of 25, when I simplify 25, when I write it as its factors, there's not 3 of these 5s. So if this was a square, I could simplify this, but it's not. So I'm going to have to leave it as this cube root of 25. At the bottom, we've got, let's go ahead and look at this all spread out. So we've got 6 of these things. And remember, if this is a 3, then I can take 3 out as 1 and another 3 out as 1. So this would come out as an x, and this would come out of the radical as an x. So my final answer here would be the cube root of 25 over x times x, which would give me the x squared. Now we have a little bit of a shortcut here. If you'll notice, if 6 is my number here and I divide it by this cube, I end up with my square. And so that's a little bit of a shortcut. And let me go ahead and show you what happens if it doesn't work out perfectly. So let's look at, let's say, the square root of x to the 7. And so if I have, if I do this, 5, 6, 7, and then I've got 2, 2, 2, you see I have this one that is going to be left over, and so my simplified answer here would be x times x times x, which would be x cubed, and the leftover is going to stay in the radical. So if I use that shortcut, which was just division, and I've got 7 divided by 2, I get that 3 as a whole number, and then this is my remainder. So the 3 becomes the exponent on the outside, and the 1 becomes the exponent for the inside. And we don't put it, I'm going to put it in pink to show it is here, but whenever it's a 1, we don't write it. Okay, so this is something you want to keep in mind that will help you a little bit, a tiny bit of a shortcut for you. So let's go ahead and simplify some of these. And very much like fractions, fractions must be simplified to be correct. The same thing with our radicals. We need to simplify them. And this is also going to help us in the future to be able to add them together or subtract them. And how we're going to do this is we're going to write the prime factors. And so let's look at the square root of 50. Now after you do this a little bit, you'll probably be able to do it without having to go through the process of writing the prime factors. But if this is giving you fits, then you want to go ahead and do the whole process. So I've got the square root of 50. I know that's 2 times 25, but 25 is not prime. I want to get it all down into the primes. And so now I've got 2 times 5, which is 10. 10 times 5 is 50. Remember that this is a square here. And so what we're looking at is 2 that are alike will come out as 1. And so my simplified answer here will be 5 on the outside with the 2 left on the inside. You want to pay close attention to whatever your root number is. If the root number is 2, like it was here, then we're taking 2 inside out as 1. The root number here is 3, so that means we need 3 things underneath this radical that are the same. Okay, so let's think about it. Without drawing my factor tree, I know this is 4 times 10. 4 is 2 times 2. And 10 is 2 times 5. So then look, there I've got 3. They're going to come out as 1. So my answer will be 2 on the outside times the cube root of 5, what's left inside. Now, hopefully you heard me say 2 times. We don't put the times dot here or anything else, but when this number is next to this radical, we are multiplying. So you want to keep that in mind also. So with this one, I've got a 6 on the outside already, and so I will be multiplying it times whatever else I bring out. So let's go ahead. I'm going to break down 200. I know that's 2 times 100, so I have 2 times, and 100 is 10 times 10. We're looking at the square root, so I'm going to take these 2 out as 1. So I end up with 6 times 10 times the square root of 2, and I want to finish that out. So we would have 60 times the square root of 2 as our final simplified answer. Okay, so let's go ahead and let you try a couple of these. before we move to the fractions, or the division, I guess. All right, so let's go ahead and try. All right, here we go. We've got 4 problems. The cube root of 4 times cube root of 3, the square root of 8 times the square root of 2, the cube root of 270, and the square root of 36 over x to the 6. Okay, so you know the drill, or hopefully you do. Hopefully you've been watching the videos. I've noticed a few people aren't watching the videos, and how do I know that? Well, some of our videos have bonus problems, and you're not getting those. And some people have done some work when there wasn't a video posted yet. So it's really important. This is your classroom part of it. If you understand the math, that's great. But if you're having problems, you need to watch the videos. Okay, so go ahead and pause it and then work it, and then come back and check your answers. Okay, so check out your answers. Here we couldn't simplify this any because it's a cube root, and 12 is 2 times 2 times 3. There aren't any 3's. Here, after I multiply, then I can see, oh yeah, the square root of 16, that's 4. Here at this point, you might notice that you could take the cube root of 27. If you did like I suggested the other day in my other video with printing out something from the internet with a list of squares and cubes, you would know that the cube root of 27 is 3, and then 10 would stay inside. Here with this one, we could take the square root of 36, and then remember our little shortcut here. 6 divided by that root number gives me the 3. Okay, great. So let's go ahead and move to the next part of this. Okay, so remember I can't take the square root of 7, but I can't have the radical here. So if I write it like this, then I can simplify the fraction in here, and that at least gets a number out of the denominator. So we can do that. If we've got, remember everything has to match, so I've got the cube root 54 over the cube root of 2. Can't do anything with this 2, so I'm going to take it and stick it all under one radical, and then I can simplify that to 27, and we just saw that we can take the cube root of 27 to give us 3. Then we want to look at what happens when we're looking at some letters. Let me give myself a little more space. Now at this point I could simplify this x squared But I still want to do the same method I've got going on here. I want to stick everything underneath and then simplify. So underneath I'm going to have x. We've got those quotient rule, exponent rules going on. 3 minus 2, 8 minus 3. Okay. Then I'm looking at, can I simplify this anymore? And I can't simplify the x anymore, but I can simplify the y. So we're going to pull the y, some of the y's out. And when I do that, remember 5 divided by 2. So I've got 5 divided by 2. That gives me 2. So this will be my out exponent. And then I'm going to have a remainder of 1. Move this up a little bit. I'll have a remainder of 1. So this will be my in exponent. So on the outside, I will have y squared. On the inside, I'm left with the x that we couldn't take out. And we've got 1y that has to stay inside. Okay, let's do one more like that. So everything's already underneath. Okay, again, quotient rule tells me to subtract. So underneath I'm going to have 10 minus 3, 7, 12 minus 3 will give me 9. Come over to the side here, 7 divided by 2, 3, this is going to be out. With a remainder of 1, that will stay in. 9 divided by 2, 4. With a remainder of 1, so the 4 is out and the 1 is in. So that gives me a final answer of x cubed. Well, I'm going to run out of space, so I'm going to move us down a little bit. That's going to give me x cubed out, y to the 4th out, and inside I will still have 1x and 1y. Okay, so that's a real quick, short little lesson, but it is an important one because we will be dealing with this a lot for the rest of the semester. So be sure that you're understanding this very well and get 100 on that homework. I'll talk to you later.